it is known that our marine ecosystems are these rich and large habitats that are economically and ecologically very productive. We know that there are a lot of relationships and interactions that are constantly occurring in this ecosystem, some of which we have the privilege to observe as humans. So one of the main interactions that helps in structuring an entire ecosystem, and one that I will focus on throughout my presentation, is predation. So while the importance of predators in food webs has been well accepted throughout literature, and there's a ton of examples, predicting the effects of predators in food web dynamics is a total different story. So in order to predict these effects that predators have on an ecosystem, we must first dive into the idea of something known as predator-prey interactions. So the strength of these interactions is typically quantified via a predator's functional response. So you're probably wondering, what is a functional response? So a functional response basically describes how prey consumption by a predator changes as a function of prey density. So for my project, that's exactly what I want to do. I want to quantify how the consumption of hard clams, which is our prey item, that is eaten by spotted eagle rays, which is our predator, changes as a function of hard clam density. So in order to estimate the parameters attack rate and handling time, which are both necessary for a functional response, I will need to model the time between feeding events and fit a truncated exponential distribution. So if we take a look at our exponential distribution graph right here, we can see that the time between feeding events at low prey densities is highest due to being limited by encounter or capture rate, which is also known as attack rate. Whereas at high prey densities, the time between feeding events is lowest due to being limited by the time it takes for the predator to consume the prey, which is also known as handling time. However, with spotted eagle rays, there's still some uncertainty when predation events are actually occurring. So that's where passive acoustics will come into play for my project. So a recent study has demonstrated the ability to document mollusk consumption through peak amplitudes. So if we take a look at this graph, the peak amplitude would indicate our first, or just in general, a predation event. So understanding the strength of interaction between spotted eagle rays as both an endangered and pest predator species can provide insight on predator-prey interactions and predict potential impacts that these predators have